Hey guys, it's Solbyte, and today we're going to be going over polymorphism again. I decided to make a part 2 to polymorphism. If you guys have not seen part 1, I went into detail about how we can use polymorphism for many different cases using base class pointers, and how we can manage derived objects using those pointers. But in today's example, I kind of want to go over some more of the types of polymorphism. That way you guys kind of have a much clearer and more, a much fuller understanding of what polymorphism actually is by its definition. So polymorphism has two types. There's compile time polymorphism and runtime polymorphism. So the basic definition of these two types is compile time polymorphism is when the program decides what members or functions to run at compile time, and runtime polymorphism is when the program decides which functionality should execute at runtime. So yeah, basically it's just the program deciding what to do either at compile time or at runtime. And these can look very different. There's many different cases where some things are decided at compile time, some things are decided at runtime. But in terms of polymorphism, I'm going to show you guys 3 examples today, 2 going over compile time polymorphism, and 1 going over what exactly runtime polymorphism is, which we've actually kind of covered runtime polymorphism quite a bit. I mean, even in abstraction, we were kind of doing a little bit of runtime polymorphism. So, but today we're going to go a little bit more in detail about the compile time polymorphism and a little bit, and just a little bit more into the definition of runtime polymorphism. So the first example is function overloading. So this will happen when we can create, so basically what we can do is we can create 2 functions of the same name, but depending on the parameters that are passed into that function, decides what function actually runs at compile time. So let's kind of show an example. So firstly, I have a base class animal and a cat class that derives from animal. So we're going to go a little bit more into this during the runtime polymorphism. But for right now, just basic constructor, a eat method here, and then some protected members here. So what I want to do is I want to create 2 functions called eat. However, I want them to behave differently depending on what parameters are passed in the main function. So let's go ahead and do this. So firstly, let's go ahead and actually pass in a parameter. Let's just do, probably just do food. I think that's probably a good one. We'll do string food. So, and then here, we'll leave it open-ended to show what food the animal is eating. All right, and now what we're going to do is I want to go ahead and copy this function, and we're just going to add it down here as well. But this time, let's say we want to pass in how many grams of food. Yeah, let's do that. Let's do the grams, the amount of grams of food. So we can do is eating, we'll do grams, and then we can just do this, grams of, yeah, we'll just do that. Because I'm trying to think of what food string I would end up passing in. So one thing I do want to go ahead and do really quick is I actually want to show you guys some new syntax that you guys may not be familiar with that is very good and very useful for strings and objects that are passed into functions. So whenever a string or an object is passed into a function, these are regarded as kind of expensive because they can take a little bit longer, and they also, depending on what we do. So here, I'll just show you guys a little bit of an example before we do this. So let's take Max and let's give him something to eat, and let's just, for the sake of this, create a string, and we'll just call it food. Why not? And then let's say pizza. So we have an animal eating pizza. That's kind of concerning. So now what we're going to do is we're just going to go in and pass in food, right? And this is, like, it works, by all means necessary, but it's not really good, I guess. I mean, especially as you want to pass in different types of parameters, especially objects as parameters. This is not as good, because what is happening is, if you guys don't know about pass by value and pass by reference, what's happening is it's actually copying this string, right? Which takes, a lot more memory than integers or doubles. It's copying this string into this function. So now, whenever this function is running, we basically, like in memory, try to imagine, we basically have two food variables. And I mean, obviously, we're going to be okay running it, but as far as efficiency goes, especially as we build bigger and better programs, we want to kind of avoid doing this by all means necessary, especially for objects. So the way that we can do this, or kind of fix this, is we're going to have it pass by reference instead. And another good practice is to add const. And what this is doing is basically, since now it's passing by reference, what this means is, I mean, if a little bit of a reminder, if anyone doesn't know, is now it's actually passing this variable itself. It's not copying it into the function. It's now actually, like, the actual variable food is being passed and used in this function. So, and that can, I mean, in our case, like, it shouldn't be a problem to leave out const, because it's not really mutating anything. But, as bigger and more complex functions come about, it's better to add const if you don't want the variable that is passed into this function to be mutated in any sort of way, whether that's indirectly or just, mistakenly, So, yeah, definitely const, and then the reference for string food. So we are passing by reference here, and with const, we are ensuring that whatever variable is passed by reference here is not mutated in any sort of way at all. So just a little bit of syntax. I just wanted to show you guys this because we will be using it in the other two examples. So just wanted to go ahead and get that out of the way. So anyways, back to function overloading. So here we clearly have two different functions. We have two eat functions, right? Now, what's really cool, obviously these functions are different, they behave differently, but what is cool is we are able to use both of these functions because of function overloading. So for this one, let's specify the amount of grams. Let's just say 2 grams of pizza. Why not? So now let's go ahead and go to the terminal and just see what we can output. If I can spell animal, there we go. And so we have animal is eating pizza, and animal is eating 2 grams of pizza. In this constructor, I made it where every animal is called animal. That way, in a later example, we can kind of see what object is an animal, what object is a cat, etc. So, but for now, yes, this is working just fine. So that's awesome. So this is a form of polymorphism. It's not runtime polymorphism, but it is a compile time polymorphism example. All right, now let's go into the second example, which will go over operator overloading. So this is when, I mean, it'd be easier just to kind of show it, but basically operator, all right, so now we're going to go into the second example, which will be covering operator overloading. So not function overloading, now operator overloading. So let's say we have a class number, right? So this will just be a number object, right? And we will just have everything be public for this. And we will create an int of num. Let's do num. So there we go. And then make sure to add the semicolon, of course. So anyways, now what we want to do is create two objects down here, and I would really like for the or actually let's do a constructor first up here. Yeah. Let's do that first. That way we can actually fill in what is needed. So let's do this, and then we are just going to assign num to n. Okay, there we go. Nice constructor there. So now let's go down here, and let's say we want to do give number a, and we will assign it to the value 1. Okay, and then we'll just do the same thing for number b, assign it to 2, and let's try to do some addition with this right now. All right, let's do a plus b. All right, so these are two number objects we want to add together, right? However, we can't do this because the program has no idea how to handle these two objects with this operator. It has no idea what to do with these data types. Operator overloading allows us to use operators like this for specific data types like objects. So how do we do this? All right, so what we're going to do is we are going to create a function, right? And this function will have the return type of number. So we are returning a number object out of this function. Okay, so, and then what we're going to do is use operator plus. All right, so what this is saying is we are creating a functionality for the plus sign operator. All right, so now let's have it where we can pass in a number reference, and we will just we'll call it n. I guess it's yeah. We'll just do n. All right. And so what this allows us to do is it allows us to define the behavior of when this operator is trying to be used for these two different objects here. So we will basically return, we'll do num, and then add it to n.num. All right. So what this is doing is it's adding the num, which is here in this object, and it's adding it to whatever number object is passed into it and accessing its num member to add it to the current num member. All right, so now as you can see, the red line has gone away. And so now let's just kind of do some cout functionality here. That way we can kind of see what is what and be able to go from there. So I'll just create some stuff like this really quickly. Okay, error here. I don't know why. Wait, what? Oh, wait, sorry. Yeah, so we'll do a.num. All right, so I'm going to copy this down here. Show b for this one. And then I want to cout c, and we will get c.num. Perfect. So let's go ahead and run this code. We will go ahead and compile and .cpp and run it. And as we can see, a equals 1, which it does, b equals 2, and added together, we get 3. Awesome. So this is another form of polymorphism. This is compile time polymorphism. And yeah, it allows us to be able to use operators like this, including other operators like the minus sign or the equivalent sign, right? If you wanted to get a Boolean comparing two different objects. So, which can really be cool as well. So, but this is just a simple example regarding the operator overloading functionality with polymorphism. All right, and now for the last example, we're going to cover runtime polymorphism, which, if you remember, is the program deciding what functions to run at runtime, right? Depending on the specific object. So firstly, I'm just going to kind of delete some of this actually. And what we want to do is we want to implement a example regarding function overriding. Now, this essentially is what we were doing in my last video. We were using the virtual keyword to create a virtual function that would be overridden if we were using a cat object instead of just an animal object, right? So let's do something kind of similar here. All right. So let's go ahead and make this a virtual function. Virtual. And so what this means now is that at runtime, the program will decide what function to run based on whatever overrides this function here. So let's go ahead and create the eat function down here for the cat. And we'll do kind of the same thing. We'll just do string reference food. And we're going to add the override keyword. This actually isn't needed, override, but you can put it there. I always put it there. So yeah, we're going to just have it where we want, I don't know, the cat to eat differently, I guess. We'll say, instead of eating, let's say is nibbling. Yeah. We'll just do that. So we'll say name is nibbling. Is that how you spell it? Nibbling? I think so. I don't know. I could look stupid right now. I don't know. But we'll just go ahead and do that. And then add basically the same functionality for the cat. So cool. So override. So what happens is that this is function overriding, and this function will be overridden at runtime down here. So let's go ahead and actually implement this for Cooper. Let's do that. So, and what we want to do is we want to create an animal base class pointer, say aptr, equal to the memory address of Cooper. All right. So now we can come down here and we can do aptr and call the eat function, and let's have it where cat food. Let's just do cat food. Perfect. So now let's go ahead and try to run this code and see what happens, right? And I'm going to show another example after this as well, just so that way you guys can kind of really understand what's going on. So cat is nibbling cat food. So this decision to run this function instead of this function is made at runtime, right? Whenever the function, like whenever I typed in, the execution file, that's when the decision to run this function was made, okay? Compared to a compile time decision instead. So very key, very important. And if we create, if we do eat for max, and let's just do animal food, why not, whatever that is. And, we can run this again. We can see that, animal is eating animal food and cat is nibbling cat food, right? So we can see that the function right up here still exists. It can still execute, right? But the decision on what function to run based on the object is made at compile time, okay? So hopefully that makes sense. I understand that it could be a little confusing at times, but we kind of were doing this from abstraction all the way to this video. So we actually have a little bit of experience now using these virtual functions, even using pure virtual functions as well. I do kind of want to touch on why pointers and references are actually kind of a big deal in polymorphism. So polymorphism doesn't really happen unless we are treating the derived objects through the same common base type, right? So what we want to do for a lot of programs is we want to treat, whatever function this is in the same way that we would treat an animal object, right? So this can be very good for making dynamic programs that, it doesn't matter what kind of object or what kind of derived class you're creating an object from, it will still be able to work using polymorphism, because the most powerful tool from polymorphism is that we can treat objects in the same way while still keeping their unique behaviors. All right, and that's really only done here with pointers and references being used. So that way we can pass in derived classes and treat them in the same way, the same functionality as we would for whatever its base class is. And something very important as well is to bring up the fact that we can't exactly use this derived class or this pointer pointing to the derived class for any specific methods or members. So here we have this meow function that is not even in the base class. So if I come up here and I try to, call that, even though it is defined in the cat object, we can't really run it because of the limitation of how this kind of polymorphism works, right? So if we if we wanted to use meow, the meow function, we'd have to call the cat directly and run it in this way. All right, so we can still definitely use it, of course, but we want to have certain instances where we can, or there's going to be certain times where you want to treat derived objects in the same way, no matter what object they are, while still keeping its unique, their unique behaviors, depending on what functionality you're implementing for the derived objects. So very important. Another key example is object slicing, which I'm debating making a video on. It's a very simple topic, but then again, it probably does deserve a video of its own, but it does touch on these kind of pointers and stuff. So, and it's very important to understand, so that way you don't run into any sort of errors in your code. So I think in my next video, I'm going to cover that. And then after that, I'm going to cover some more specific topics regarding classes. And then we will, what I really want to do is I want to create a full-scale project using all of the main pillars of object-oriented programming, like, encapsulation, inheritance, abstraction, and polymorphism. And we will create a nice project using all of it. That way we can really kind of see how all of it ties into each other and make a good final product at the end of the day. So, and yeah, that's about it. If you guys have any questions, please let me know in the comments below. I'm also going to leave some resources in the description if you guys want to see some different sources speak on this. And yeah, thank you guys for watching.